Hello guys, can you hear me? Okay, I think I must be audible now. Shall we? How's it going? Hi, Nishans. Hi, awesome. Awesome. Hi, Elgali, Luli, Alpha, and Artem, I think. So, today we're gonna have our third session on DP, and in today's session, we're gonna cover some things like as I said before, we're gonna talk about LCS. We're gonna talk about LCS. And we're gonna talk about prefix sums, the different models of prefix sums, and we're gonna solve some multi-dimensional dynamic programming problems with difficulty more than 2000. And you don't need any prior knowledge to understand any of these. I mean, all of these problems, I chose them in a way that such that even if you don't know anything from before, you can understand them. And I hope that it would be helpful. Do I need to see the previous two sessions to understand this? You do not necessarily need this for this session, but I highly recommend that because we also talked about very important things in those sessions. So if you can, I highly recommend that. But in order to understand what will be discussed in today's session, I think you can understand it without having watched the previous two sessions. So, shall we start? And would you share resources for CP? Yeah, sure. I will do that. Today, we're gonna talk about DP, but I always try to share resources for CP and talk about those things as well. So let us start about this, and we're gonna talk about those things as well. Sure, I try to slow down. Whenever you thought that I'm rushing something, let me know. I will try to spend enough time on each topic so that it would be okay. So let us start. A good book. I will tell you about this. These are many things that we've discussed before. Well, for example, books are not gonna be really that helpful, but I will recommend books if you want. But let us start talking about today's topics. So, the first thing that I want to discuss with you today is an important topic named LCS. I'm gonna tell you what it says, and we're gonna solve it together, and then we're gonna talk about the other topics as well. LCS is an example of a multidimensional DP problem. So let's see what it says first. What does LCS want? Well, LCS, or longest common subsequence, states that assume you have two strings like S and T. it wants you to find that what is the greatest subsequence or longest string, what is the longest string, like let's call it L, such that you can say that L appears both in S and in T. What do I mean by that? I mean that, for example, assume that your string S is like this: 1, 3, 1, 2, 4, 3, for example. This is like it can both be a string or can be an array. I mean, for both of them it works. For example, assume that right now in here is an array, and T is, for example, 3, 1, 4, 2, 4, 2. Then you can see that in both of the arrays, a subsequence will be a sequence that we have if we remove some of our elements. So a subsequence is just a subset of our elements in order. For example, 1 to 4 is going to be a subsequence of our sequence S. At the same time, 1 to 4, you can see that is a subsequence of the second sequence as well. So you see that both of them have this 1 to 4. Also, for example, 3, 1 is a subsequence in here, or even this 3 and or any other thing that we can choose. For example, this 3 is a subsequence in here. This 1 and this 3 is also a subsequence in here. So we want to see that what is the longest possible string that is both a subsequence of the first one and the subsequence of the second one. And we presume that n is, for example, up to 2000, the length of the arrays or the length of the strings. So is the statement clear? Is it clear that's what we are looking for? Hello, no name. We will discuss that as well. We have discussed such things, but we will discuss that again. Okay, so this is what we are looking for. So what do you think we can do? It can also be strings. For example, you can say that one string, you can define two strings. For example, one of them is x, y, x, z. For example, x, y, z. And t can be, for example, y, z, x, y, x, z, y, for example. So what is the LCS of these two strings? What is the longest string that is both a subsequence of the first one and it is a subsequence of the second one? A subsequence of the second one. A subsequence of the second one. Subsequence of sure, I will drop the links in the comments. I will drop the links in the comments. So for example, drop the links in the comments. What is so for example LCS here x y x? So for example LCS here x y x. So for example it makes sense. It seems like it makes sense. So for example, we can have x, then y, then x, then z. In here also we can have x and then y and then x and then z. In the second one they are consecutive, but they do not necessarily need to be consecutive. They can be both consecutive or non-consecutive. So yes, for example, this works. This is a common subsequence. But is it possible to make it even larger? You need to just check all the common subsequence and see what it is. For example, zy is also a subsequence that is a subsequence of both of them. That is a string that is a subsequence of both of the strings. But the length of that one is 2, the length of these red ones are 4. So if we consider the greatest one in all of them, is it okay? Is it okay now? Okay. Okay, good. So if we consider the greatest one, 4 is gonna be the greatest one. So the length of the LCS of these two, the LCS is gonna be x, y, x, z, and the length of LCS, length of the longest common subsequence, is gonna be 4. So zy is also a common subsequence, or is a CS, but it's not the longest CS, it's not the longest common subsequence, it's not the LCS. Right, so now let's see that how we can calculate LCS. YZ, XYZ, let me see if that's also, yeah, that makes sense as well. So yes, very good. In this case, it seems like XY, XZY is also a common subsequence of both of them. X, Y, X, Y, Z, and in this one also X, XZY, not X, okay. XZY, and in this one also X, Y, X, ZY. Yes, this is even bigger. So we also have an answer for 5. So 4 is not the longest one anymore. So we consider all the possible common subsequences, and we consider the one with the greatest length, with the longest one. So as you said, yes, this is X, Y, X, ZY. And this is also X, Y, X, Z, Y. Sorry, this is 5. The length of it is 5. So for both of them, X, Y, X, Z, Y is going to be a subsequence of them. And the length of this greatest subsequence is going to be 5. Yes, right. Great. So we now know that exactly what LCS means, what LCS is looking for. The longest common substring, that's going to be an easier question. Maybe we will consider that in the future, but that's going to be easier. So right now we're talking about the longest common subsequence. The difference between subsequence and substring, as you might already know, is that substring must be consecutive, but subsequence does not need to be consecutive. So now when we want to calculate the LCS of them, what do you think can be the states of our DP? What do you think the state of our DP can be? How can we define some states? Is there anything that comes to your mind? DP of I, like LCM, I think you mean LCS, right? Which starts at I. DP of I and J until index I in the first string and J on the second string. Yes, these are good ideas. These are good ideas, guys. Thank you. Yeah, nice. So what we can do is like this. Instead of, what I want to do is that instead of just solving the problem, for the whole strings S and T, let's solve it for every prefix of S and prefix of T. So what I mean is that instead of, assume that the length of S is, for example, n, the length of t is m. And n and m are both up to, for example, 2000, for example. So what I can say is that instead of trying to solve the problem for the whole strings, I define many more sub-problems, and I want to solve all of them, like what we always do in DP problems, like what we discussed before, that in DP problems, what we do is that instead of solving some main problem, we try to define so many sub-problems instead of just solving the main problem. We try to define several sub-problems and try to solve all of them. So in here, what I define is that instead of just trying to find out what is the LCS of, for example, S and T, for every I and J, I see that what is the prefix of this prefix of S from element number I to element number I, and this prefix of T from element 1 to element J. For example, if again if my strings are, for example, x, y, x, z, z, and this one is z, x, y, z, x, for example, and a y as well. So the length of this one is 5, the length of this one is 6. Instead of just trying to find out what is the LCS of these two, I try to make a table of size 5 by 6, or even more than that. I also consider 0 as well. I mean, I can be 0 as well. I can be 0, 1, 2, 3, 4, 5. J can be 0, 1, 2, 3, 4, 5, 6. So for I have 6 cases. For J, I'm gonna have 7 cases. 6 cases for 0 to 5. For J, I'm gonna have 7 cases for 0 to 6. So I make this table. In each cell of it, I write that what is the LCS if I only consider the first I letters of S and the first J letters of T. So if I consider the first 0 letters of both, I know that the LCS is going to be 0 because I have 2 empty strings. So the greatest common subsequence of them is going to be 0 as well. What about 1 and 0? Can you say that? What about 1 and 0? If I consider the first 1 letter of S and the first 0 letters of T, then what is the LCS? So 1 and 0 says this. Exactly. Again, it's going to be 0 because one of them is empty, so it cannot have any subsequence. So any sequence with length greater than 0 cannot be a subsequence of the second one, so it cannot be a common subsequence. So these are all 0. These are all 0. The first row and the first column, because one of them is from one of the strings I'm taking 0, it's gonna be 0. But for example, what is 1 and 1? 1 and 1 means that from the first one we have x, from the second one we have z. What is the LCS of that? Yes, again 0, because they are different. The x and z, it's not possible that you pick anything that is gonna be the subsequence of both of them. What about 2 and 1? If we take x and y from here and z from here, again there's no common character between them, so the length of their greatest common subsequence is gonna be 0. So if I gonna add another row in here, this is 0 and this is also 0. What about 3 and 1? Again, that's gonna be 0. What about 4 and 1? 4 and 1 is gonna be 1, because we're gonna have z in both of them, and z can be a common subsequence in both of them. And also 5 and 1 is also gonna be 1, because z can be a common subsequence in both of them. So for 5 and 1, it's gonna be 1. Also, if you consider the next row as well, this time also we know that about the first row, About the first row, it's gonna be 0 because x is 0. But when we consider 1 and 2, both of them have x. So our answer can be 1 because both of them have x. The first character of s and the first two characters of t. Both of them have x, so it's gonna be 1. If we consider 2 and 2, it's gonna still be 1 because x is the greatest common subsequence. If consider 3 and 2 still 1, 4 and 2 still 1, and 5 and 2 is still 1 as well. Because we can either match the x's or the z's. So this is also 1. When you consider the next row as well, this time you are considering 3 cells, 3 elements from T, and you will start from the first elements in S. So x and z, x, y, the LCS of them is gonna be 1. You have x in most of them. When you consider the first two characters, what is the LCS then? What is the LCS of x, y, and z, x, y? Exactly. It's gonna be 2. Because now you have both x and y. So this is gonna be 2. And if you consider the whole string, the whole first string and the first 3 characters of t, that is also gonna be 2. We have nothing better than x. And we can continue this, and if we also consider the last column, for the last column, if we consider the DP of, for example, 1 and 6, it's gonna be 1. 2 and 6, there's gonna be x, y in both of them, so it's gonna be 2. 3 and 6, we're gonna have x, y, x, so it's gonna be really 3 in both of them because x, y, x is a common subsequence in both of them, so that's gonna be 3. And if we go forward for the last one, we have x, y, x, z, z. And the second one is z, x, y, z, x, y. What is the LCS of them? What is the LCA of these two? Exactly. It's gonna still be 3. Exactly. Still x, y, z, x, y, x is gonna be the greatest common subsequence. So as you see, like always, DP looks like we are making our own work harder. Why? Because as you see, instead of solving only one instance of a problem, we're trying to solve several instances of the same problem. So why someone must do that? I mean, how is that gonna be helpful? Because the good news is that why do we do this? Because these subproblems, the answers, or let me say that these subproblems are gonna help each other. Help each other to be solved. So it means that when you solve one of the subproblem, in another subproblem you can use the answer of that one. So this is why we try to find the answer for several subproblems. The point is that when you solve a subproblem, you might use its answer, when you save its answer somewhere, later on, when you want to solve another subproblem, you might use that value. So this is the reason that we're gonna save all these answers to all these subproblems, and you don't want to just solve the problem for the general case, but also for all these possible subcases. So, for example, assume that we want to solve this DP of I and j. We consider the first I characters of S and the first j characters of t. So this is my dp of I and j. How can I solve this? What are the things that I can say in here? When I consider the first I characters of S and the first J characters of T. Well, there is gonna be several cases. Okay, there is gonna be several cases. If I want to find the LCS of the first I characters of S and the first J characters of T. I want to find the LCS of these two strings. Well, I can say that LCS always looks like, for example, in here, if you look at it, LCS always looks like we're matching some characters to each other. For example, in here, it's like I'm matching this X to this X. I'm matching this Y to this Y, and I'm matching this X to this X. So I can say that LCS looks like we are trying to match some characters from the first string to the second string. So what LCS looks like, it's like we're gonna, if we have two strings, LCS looks like we will choose several characters in here and also several characters in here, and then match these characters with these characters so that in each of these matches the characters on the both sides are the same, and also these are in order. So for example, if this one will be matched with this one, then when you consider a character to the right of it, if you have also chose that one, this will be matched with someone to the right of the previous one as well. So LCS looks like this. It's like you consider several characters from the first string and the second string and you match them to each other. This must be equal to this. Then this must be equal to this. And then this one must be equal to this one. And this one must be equal to this one. So it's like we're matching several characters from the first string to the second string. So the first fact that I can say in here is that when you consider these I characters, these are characters from 1 to I, and these are the characters from 1 to J from T. There's something that you can say about these last characters. You can say that these last characters, if they're gonna be matched, if there are two cases. Let's consider the last characters, or in other words, the last characters are going to be S sub I and T sub J. There are two cases. Either I'm going to use both of them. What do I mean by I'm gonna use both of them? I mean that I will, in my matching, both in this matching that I have, I'm gonna use several characters. You know, several characters will be chosen like these ones. Several characters will be chosen and they will be matched to each other. So, and several characters are not gonna be used. Several characters will be ignored in here. Right? So there are I have several characters that I will ignore, I will not use them at all. And some characters that I will use and I will match them to each other. So I say that when I say that there are several cases, one of them is that I'm going to use both of them. So they are both going to be matched with something. And the other case is that I'm not going to use both. I'm not going to use both. So at least one will be ignored. if I'm going to use both of them, so this is the case that both of them will come in that matching. The other case is that at least one of them doesn't come. So if I'm going to use both of them, I mean both of them are in the matching, there is a fact that they must be matched to each other. So if they are both used, I can say that they must be matched to each other. Because if this one is gonna be matched with another character, and this one is gonna be matched with another character, this does not abide the rules that we set. We set that any character must be matched with, if it's gonna be matched with another character, these must be in order. I mean, these lines that we draw here will never intersect each other. We never have matches like this. We cannot have matches like this. These two match and these two match. They must be in order. If a character comes after another character, its match, its pair also must come after the other character as well. It is not possible that their matches do not match with, if their matches do not have the are not in order. So in this case, they must be matched with each other. So is it clear so far? Aditya, is there any issue with it or the other guys? If you're completely okay with that, please use this emoji or say that in the chat. Put a plus maybe. So I'm saying that if I'm gonna use both of these characters must be matched with each other. Okay, awesome, nice. Nice. Thank you for the emojis. So I'm gonna say that if both of them, so if S, I and TJ are to be a part of the final CS, they must be matched with each other. No, I'm not saying about the final CS. I'm not saying about the final LCS. I'm saying about this, I'm only talking, that's a very good question. I'm only talking about this sub-problem. dp of I and j. In this sub-problem, I and j are the last characters of the string. So I'm saying that, sorry, I'm just talking about this sub-problem. This sub-problem of dp of I and j. In this sub-problem, I and j are the last characters. So I'm just saying that I'm not talking about this in the general strings that we have. I'm not talking about S and T. I'm saying that if you want to match S of 1 to I with T of 1 to J, if you want to match these two, then in this sub-problem, if you're going to use character number I from the first one and character J from the second one, these two must be matched. So I'm not saying that in the general string that would happen. I'm just saying that in this sub-problem, for example, if you consider x by x from the first one and z x y z from the second one, then if you're gonna use both of them, these two must be matched with each other. For example, in this case, they can't be matched with each other because one of them is x, one of them is z. But anyway, in this sub-problem that you only have these characters, so the rest of the characters are ignored. In this sub-problem, if you're going to use the last characters, you must match them with each other. Is it clear? So I'm just saying that, I'm just saying all these facts. I'm only talking about this sub-problem of dp of I and j. So this is the last character here, and this is in the general string. There are several characters afterwards as well. So maybe this will be matched with this one, but this will be matched with something after that, and that would still work, and there's no problem. So in the general string, it's not like this. But if I'm gonna only use the characters that I have in these prefixes, then it's not possible that both of them will be matched to another thing. Okay, awesome. Yes, so if I use both of them, both of these last one, I must match them to each other. This case is not possible. So in this case, I can say that definitely S sub I must be equal to T sub j. Otherwise, I cannot match them. So I showed that if I'm going to use both of them, they must be matched with each other. And when they are going to be matched with each other, S of I must be equal to T of j, T sub j. That's the rule. And then what is going to be our answer? Then my answer is going to be dp of I minus 1 and j minus 1, because now I can remove this character and remove. When I removed it recursively, solve this subproblem, this is where the answers to the smaller distances are going to help me to answer to this subproblem. When I'm going to solve this subproblem, I'm going to use the answers for the smaller subproblems that I've solved already. So I'm going to use dp of I minus 1 and j minus 1, and I'm going to add 1 to it because I've had one more character here that are going to be matched with each other. So this case is going to look like this. I can say that if S of I was equal to T of I, and guys, do not forget that in here when I'm explaining, I'm using one based ordering, indexing. But in your code, you're gonna need to use zero based indexing, so you need to convert them accordingly. But anyway, so in here, I presume that my characters are S1, S2 to Sn, and T1, T2 to Tm. When you want to do it in zero base, you have S1 to Sn minus, S0 to Sn minus 1, and T0 to Tm minus 1. So the whole thing that you need to do, the whole thing that you need to change is to add a minus 1 in here and here. And this is j. When you want to convert it to zero based indexing, you're going to need to add only a minus 1. So that instead of 1 to n, you consider, or 1 to I, you consider 0 to I minus 1. When you do zero based indexing, instead of 1 to I, the indices is going to be 0 to I minus 1 here. And in here, the indices is going to be 0 to j minus 1 instead of 1 to j and 1 to I. So you're going to compare S of I minus 1 and T of j minus 1. Is it clear? So if you're going to use zero-based indexing, you're going to compare I minus 1 and j minus 1, not I and j. So let me also in here, because in your code you must also use zero-based indexing, let me update the code so that I also use zero-based indexing. So let me first, let me start the whole code and we're gonna update it step by step. Why it doesn't work? Let me see what is wrong with this. Okay. So when we have a for I from 0, I less than or equal to n, n is the length of s, n is s dot size, and m is t dot size. So I'm gonna start I from 0, I less than or equal to n, I plus plus, and then I'm gonna have another for int j equal to 0, j less than or equal to m, j plus plus. I'm gonna say that if I was 0 or j was 0, I show it like this. If by the just an exclamation claim, you can have you can show that with some exclamation sign. You can just see that if that value is 0 or not. If it's like if not of I or not of j, it means that if at least one of them is 0. Then I can say that dp of I and j is 0. Because for one of them you're considering an empty string. Else, this else part is the important part of it. else I can say that if s of I minus 1 and j minus 1, sorry, s of I minus 1 is equal to t of j minus 1, I can say that dp of I and j is equal to maximum of its current value. Its current value is 0, so definitely maximum of these two is gonna be the other value. But I'm just writing it so that you don't forget that we have several cases, and this is one of the cases. When you have several cases, when you want to update your value from several cases, each time that you're updating it from one of these values, you should say that this value is equal to maximum of itself and this new value. So this way you're taking the maximum of all. So when you have several cases, each time you need to say that your value is going to be maximum of your current value and this new case that you have. dp of I and j and dp of I minus 1 and j minus 1 plus 1. This is the case that you will match the character I minus 1 from S and the character j minus 1 from T, and you will check that, and now you will recursively check that what is the answer for the first I minus 1 characters in S and the first j minus 1 characters in T. So these are 0 to I minus 1, the first I characters of S, 0 to j minus 1, the first j characters of T. You will now recursively solve these parts and see that what is the maximum LCS in here, and then you will match these two at the end as well. So whatever was the maximum matching in here, you can add 1 to it. So it's gonna be dp of I minus 1 and j minus 1 plus 1. Is it clear so far? So this is the case that I'm gonna use both of I minus 1 and j minus 1. I'm gonna use both of these ones. And because now I'm using zero-based indexing instead of one-based indexing, zero-based indexing means that my indices have started from 0 instead of 1. I should now here use I minus 1 and j minus 1. When they are equal, we say that it is possible to match them. We do not, so far I'm not greedily matching them. Even if we greedily match them, that is true. But so far this is not what I'm talking about. I'm just saying that if there are two cases, either I'm gonna use both of them, then they're gonna be matched with each other. They need to be matched with each other if both are gonna be used. And if they will be matched with each other, they must be equal, and they will be updated from dp of I minus 1 and j minus 1. Okay, so this is the first case. But it is also possible that I'm not going to use both of them. The rating of this, I'm not yet talking about SCF problem. So this is the classic problem, and then we will move on to the problems. Why didn't we use? Because I'm using zero-based indexing now. I mean, now my indices are from 0 to I minus 1 instead of from 1 to I. So the last character of the first I characters of S is I minus 1. The last character of the first J characters of T is J minus 1. Right? Okay. Awesome. So now, what if I'm not gonna use both? So at least one wouldn't be used. Well, again, there is gonna be two cases. Either I won't use S of I minus 1, or I won't use T of J minus 1, or both, or I'm not gonna use both. But I'm sure that at least one of these two will happen. So if I consider these two cases and I see that in each of the cases, what happens, what is my maximum answer? If I take the maximum of these two, that is gonna be my answer of this case. Because at least one of these two will happen. These two cases also intersect. I mean, there are cases that we don't use s of I minus 1 and we do not use t of j minus 1. They will be calculated in both of these, because they are both in the group of cases that s of I minus 1 is not used, and they are in the group of the cases that t of j minus 1 is not used. So these two sets intersect. These two cases intersect as well. There are cases that is common in both of them. So if I consider each of these cases and I see that what is the answer in that case, I can take the maximum of these two and that's going to be my answer. And yes, exactly. It's going to be exactly like what you're talking about here. It's going to be maximum of dp of I minus 1 and j and I and j minus 1. There's no additional plus 1 in here because there's nothing that we've matched. In the previous case, we matched s of I minus 1 and t of j minus 1. So when they were matched, I could just say that, if they were matched, I could just say that, okay, I've added one more match. But here, I'm not matching anything. I'm just saying that this case that I'm not going to use this index I minus 1 from S, I can just remove it because it's not going to be helpful. So I can update my answer from dp of I minus 1 and j. I minus 1 means indices from 0 to I minus 2, and j means the indices from 0 to j minus 1 from t. So this case is dp of I minus 1 and j. Also the case that I'm not using t of j minus 1, I can say that, okay, so let's remove that if you're not going to use it. So in this case, I'm just saying that I'm not using this. So it's like I need to see that what is the LCS between this part and this part. Which is gonna, in this case, we had the LCS between this part and this part. So in this case, we need to see what is dp of I and j minus 1. So these are the two cases. And as I said, they have the same cases as well. I mean, they have some common cases as well that I'm not going to use both. But because at least one of these two is not going to be used, I can take the maximum of these two values. Because the maximum that I can get is the maximum of these two possibilities. My answer will lie in at least one of these two possibilities. So it cannot be more than maximum of these two. It must be calculated in at least one of these two. So in this case, my answer is going to be maximum of this. And because we don't have any preconditions for that, I can just here easily say that also dp of I and j, there's no additional if for it. In any way I do this, it's going to be maximum of dp of I and j and maximum of dp of I minus 1 and j and dp of I and j minus 1. I can also write them separately. So I can say that it is maximum with dp of I minus 1 and j. So this is the case that I'm not using s of I minus 1. And also I can say that dp of I and j is equal to maximum of dp of I and j and dp of I and j minus 1. This is the case that I'm not using t of j minus 1. So this way all my dp's are calculated, and you can see that even though it looks like I've made my work harder by doing this, but you see that how these dp's are helping each other to be calculated. When I'm calculating dp of I and j, I'm extensively using the previous dp's that I had, and this helps me to find the LCS of the whole arrays as well. At the end, my answer is going to be, dp of, my final answer is going to be dp of n and m. So you can see that how it helps me to find the final answer. And my total time, what is my total complexity then? It's, we're talking about LCS right now. Yes, our total time complexity is O of nm because we just have a 4 up to n and a 4 up to m, and then inside everything is of 1. We have just several calculations, etc. So this way, LCS using DP is solved in O of NM. So this way the problem is solved in O of NM. We just considered several cases. We just saw that when we want to find dp of I and j, there are really 3 cases. Either I and j will be matched, or I will ignore I, or I will ignore j. The only condition is for this case. In this case, s of I minus 1 and t of j minus 1, or let me write it in one base indexing in here, because it looks nicer in here. If they are equal, they just need to be equal if they are going to be matched. So in this case, dp of I and j will be equal to dp of I minus 1 and j minus 1 plus 1. In this case, I'm gonna have dp of I minus 1 and j because I is just ignored. In this case, I'm gonna have dp of I and j minus 1 because j from the second string is just ignored. So, is it completely clear? Did you completely comprehend it? Just want to make sure that if everything is okay. And if it is okay, we're gonna solve some problems now. We spent relatively a lot of time on this, but I hope that that's worth it. And now you are completely okay with this. Awesome, nice. So, great. So now let's start talking about it. Can you tell if it will work if we put the entire other 2 cases in the else block? It would work, yes. Yes, there's something we can say that even if the s of I minus 1 and t of j minus 1 are the same, we can say that we can greedily match them and say that if this is possible, this is going to be the best case if we match them greedily. But that is not the topic that I want to go into. So yes, in short answer, if we put these 2 in an else block, that would still work, because if they can be matched, always the best case is to match them, not the other 2 cases. And the intuition behind it is relatively easy as well. I mean, if you can match the last characters, what are you waiting for? Just match them. You want to ignore one of them and match this with another thing. Okay, instead of that, just match it with this. So the point is that if, I didn't want to get into it, but okay, let me say it. Even without this fact, everything is correct and your DP works. But this fact also exists, that if s of I minus 1 and t of j minus 1 can be matched, it is always optimal to match them. So in that case, you can just say that dp of I and j is going to be dp of I minus 1 and j minus 1 plus 1. If they can be matched, it is always optimal to match them, because what you are looking for if you're not going to match them, what you're waiting for, you're gonna match them later on, match one of them later on with another thing and ignore the other one. Well, instead of that, you could just match it with this one, and it is at least as good at that. So your DP can also be updated like this. You can also say that if s of I minus 1 is equal to t of I minus 1, just set dp of I and j as, just set dp of I and j as dp of I minus 1 and j minus 1 plus 1, else consider the other two cases. Else say that dp of I and j is equal to maximum of dp of I minus 1 and j and dp of I and j minus 1. So yes, we can also say that, I mean, the only difference that we've made is that if they can be matched, we just match them and we do not consider the other cases. If they cannot be matched, we consider the other cases that we ignore them. Or in other words, if you're considering the first I characters of S, the first j characters of T, if the last characters are matched, when you are calculating the LCS of two strings, if the last characters of them are matched, just the last characters of them have the same character, just match them. There's no reason to avoid matching them, because nothing becomes better by not matching them and matching one of them to another thing instead. If you're not gonna matching them, if you can match them, but you're not matching them, you need to ignore one of them and match the other one with another thing. But instead, you could just match it with this one and ignore the other one, and it is still as good at that. So still there exists an optimal answer that will match them. So this is some extra on LCS. Even without using this fact, it works, but it makes your code a bit simpler. Is this also clear? Yes, the next topic stream is gonna be graph. We're gonna have a topic stream each week. So each week on Fridays, only this week we had it on Saturday, but each week on Fridays from 12 to 4 in GMT, we're gonna have topic streams. I'm gonna start from the very beginning. So I'm gonna start when I'm gonna talk about graphs. I'm gonna start from the very beginning and then go to more advanced topics with you. But I'm gonna start from the beginning so that everybody can come with us. And then together we will move on to advanced topics over time. Yeah, good. Good. So, nice. Okay, so now let's talk about another problem. Let's talk about the first problem that we're gonna discuss today. Problem MC. It says that given two strings S and T, you can each time delete a character from S with cost 15 and a character T, or you can delete a character from T with cost 30. So we have two strings. From the first one, you can delete a character with cost 15. From the second one, you can delete a character with cost 30. You want to make these two strings the same. What is the minimum cost that you need to pay to make them the same? For example, in here you have AXB and YAB. You can remove this X from the first one. Its cost is 15. Also remove this Y from the second one. Its cost is 30. So in total, our cost is going to be 45. And the two strings are going to be the same afterwards. Both of them are AB. Also in here we have ABCD. We need to remove everything. So we have 2 times 15 plus 2 times 30, which is 90. So we have two strings. We want to remove several characters from them so that they're gonna be the same. Is O of n by m the fastest LCS algo? Yes, for now it's the only thing and the fastest thing that you need to consider. There are some details, there are some things that people do sometimes, but that doesn't matter at all. So yes, it is the fastest LCS algorithm that you're gonna use. Don't you just... that's a good idea. Yes, let me explain it. So we have S and we have T. Let me also put the link in the chat, so that if you want you can open it. So we have S and we have T. Each time we can remove one thing from S with cost 15 and one thing from one character from T with cost 30. So we want to see that what is the minimum cost to make our two strings the same. So what do you think our sub-problems can be? What do you think can be our problems in this problem? Again, like all the other DP problems, the first thing that we take care of is to define sub-problems. What are the sub-problems that we're going to take care of? Do you have any idea? Again, we have a string S and we have a string T, and it's like we're removing some characters, right? Yes, that's a very good idea. Yes. We can do it like LCS and try to find that what is the cost if we only consider the first I characters of S and the first J characters of T. So we see that for any prefix of S and any prefix of T, again, like any DP problem, the first thing that we are trying to do is to define some sub-problems. Instead of just solving our original problem, we define several sub-problems and we try to solve all of them. So what we can do is, if we consider the first I characters of S and the first J characters of T, so we have this from 0 to I minus 1 in S and from 0 to J minus 1 in T. Again, do you agree that it's gonna be a lot similar to LCS? Again, either I will remove at least one of these two. Let's consider that I'm talking about I minus 1 and J minus 1. There are two cases: either at least one in our optimal answer, at least one is removed, and there's also a case that none of them is removed. Both stay, both remain. So can you tell me that in each case, what is gonna, from which DPs I need to update my answer? If at least one is removed, from which DPs I can update my DP? Yes, right now I'm trying to calculate the cost directly. Awesome, exactly. Either I remove the character number I from the first one, the character S of I minus 1. So I minus 1 characters are remained, and I pay 15 for it. Maybe in future I will character the Jth character of T as well. But for now, for the first move, I remove this one. So as I said, again, these two cases have common cases as well. There are common cases in these two that both are removed. They will be calculated in both, so I don't need to worry about them. In both, they are calculated. So if I is removed, it's gonna be DP of I minus 1 and J plus 15. The cost of removing it is 15. And if J is removed, it's gonna be DP of I and J minus 1 plus 30. So yes, that's exactly this. If I is removed, and when I say I is removed, again, I should emphasize that maybe in future I will remove J as well. But in this turn, I'm just considering the case that I is not here. So DP is gonna be DP of I minus 1 and J plus 15. And if J is removed, it's gonna be DP of I and J minus 1 plus 30, the cost of removing this one. So this is how I can find out DPs. And again, the case that both I and j will be removed will be calculated in both of the cases. Because when I and j are both removed, it means that I is removed and it means that j is removed. So both are removed. So I can say that in both of them it is calculated. So this is the case that both of them will be removed. What about the case that this is the case that at least one of them is removed? The complement of this case is the case that both of them will remain, none of them will be removed. What can I say about this other case? What about the case that both of them will remain? Yes, it's gonna be dp of I minus 1 and j minus 1, and only if s of I is equal to t of j. Exactly. So this case is only valid if s of I minus 1 is equal to t of my j minus 1. Otherwise, this is not valid. And we should not do anything about this case. But in this case, if s of I minus 1 and t of j minus 1 are the same, it will be updated from dp of I minus 1 and j minus 1 without any additional costs. Because these two are equal, and it's like the two strings, their last characters are equal. So I can choose that and just ignore that. Okay, this is the last character that is equal. So if the string in the rest of the, if in the other parts, the strings are gonna be the same, by adding this character to the end of both of them, they're gonna be the same as well. So it's gonna be dp of I minus 1 and j minus 1. So yes, exactly. And again, like LCS, we can say that greedily, we can say that if they can be matched, it always is better to match them. And if they can't be matched, we just case by case see that we will remove each one of them. So greedily, we can say that. So this is how we can calculate this dp. This way we can calculate our answer and have our dp. And at the end, again, dp of our final answer is gonna be dp of n and m. Is it clear? Sorry. Is it clear? Let me see that. Okay, nice. So this way our dp's can be calculated. So now consider the other case. You were just saying another way to solve. You were just mentioning another way to solve this problem. That is very good. That also works. And let me bring the chats that we're talking about this. When it is zoomed, unfortunately, the scroll does not work very well. So, yeah. Yes, this idea is also true. This idea is also correct. 15. You know, the point is that what you are saying is that at the end, those two strings that remain must be a common subsequence of the two strings. If they're not a common subsequence of the two strings, then it's not possible that this is something that is remained from this string. Each time, from each of our two strings, we have s and t. Each time we will remove one character from them. So what remains is a subsequence. So if at the end we're gonna have the same string in both of them, it means that it must be a common subsequence of these two. So at the end, we must choose some common subsequence in these two. And as you said, the only thing that matters, the only thing that we care about is the length. So we only care about what is the length of that common subsequence that remains in these two. And if if it choose the length of that, for example, if it is L, our final answer is gonna be 15 times s dot size minus L plus 30 times t dot size minus L. So this is gonna be our final answer. If we choose that, how many characters will remain from the first string and how many characters will remain from the second string? If we find that out, then it's gonna be 15 times the number of other characters in S and plus 30 times the number of other characters in T. So this way also we can say that we can find our final answer. And what is the best value for L? Definitely the best value for L is to be the maximum possible. As much as it is higher, our cost will be lower because less characters are going to be removed. So less cost, we will pay less cost. So it's going to be LCS. So it's just about we calculate LCS. L is equal to the length of the LCS of S and T. And then our answer is going to be 15 times s dot size minus L plus 30 times t dot size minus L. So that could also work. We could both use LCS, first do the DP for LCS and calculate LCS, and then with this formula find the answer of our problem. Or we could do from the beginning, just define DP on this problem that we have. I mean, instead of using DP on LCS, and as you can see, this DP is very similar to the DP that we had in LCS. So we could also change the definition of DP. So we used two approaches. In one of them, we look at LCS, at the problem of calculating LCS as a black box, and we just give these two strings to it, see what is the answer, and then we apply a formula to it, and that is going to be our final answer. In one of them is just like we modified the DP that we had for LCS a little bit. We designed DP for this problem, and it's like we modified the LCS. So in one of them we saw LCS as a black box and we did not change anything in it, and we just get its final answer and do something with that final answer. In one of them we define DP for this problem and we try to solve it. Both works completely and both of them are completely okay. Is it clear? Right now we have another problem that you should go to, but you can send the link of it even here or in the comments, and we can maybe discuss about it in the future live streams. Okay. So is it clear? If it is clear, please again use this emoji or put a plus in the chat. Okay, nice. Nice. Nice, thank you. So, awesome. Now we can move on to the next problem. And guys, for further discussion, if you wanted, you can join our Telegram channel or our Discord server. This is the link of our Telegram channel. And let me also send you the link of our Discord server if you wanted to join. And if you like the video, you can like it here or subscribe to the channel. You do not need to do this really, but if you wanted to support my work, you can do that. I would be happy to do that. So let's now move on to the next character. Why I said next character, next problem. I want to discuss another problem on multi-dimensional DP now. So let's talk about it. So the problem that I want to discuss next is this one, rectangle painting from Codeforces. The previous problem was from Spudge, so it doesn't have any specific rating or difficulty. But this is one of the well-known problems of Spudge. You know, the point is that LCS, if you don't know it already, I mean, if you encounter a problem and you don't know what LCS is, maybe its difficulty is going to be like 1500 or something in total. And also this problem that we discussed, it's going to be like that. But this is something that if you hear, you can understand it well and maybe apply it in future in the other problems. And then when you know that what is the algorithm, then these problems are going to be a lot easier for you. Okay, so let me also share the link with you. This is the link of the next problem, rectangle painting. This problem says that we have a square grid of size n by n. Some cells are colored in black, all the others are colored in white. In one operation, you can select some subrectangle and color all its cells in white. And if you choose an h by w subgrid, subrectangle, then the cost of it is going to be maximum of h and w if you choose an h by w rectangle to make them white. You want to make everything white for minimum total cost. The white cells are shown with dots, the black cells are shown with these hashtags. So these characters of dots in each hashtag shows a black cell, each dot shows a white cell. So in general, so what this problem is saying is that we have this n by n grids. We want to make all the hashtags into dots or all the black cells into white cells. Each time we can choose an h by w subgrid, subrectangle, and make all of them white. If inside it something is already white, it remains white. If it is black, it turns into white. And the cost of making it white, making this rectangle white, is going to be maximum of h and w. And you have to make everything white with minimum possible cost. This is one of the problems that I said that it doesn't need any prior knowledge, you can completely understand it, but this is a multi-dimensional DP problem with difficulty 2300, 2300. So, but you will see that this problem is completely understandable, how you will solve it using a multi-dimensional DP. So, is the statement clear? Yes, and it is D1D. It's a problem D1D. So it looks like it's a hard problem, but now we will solve it together and we see that no, it's not anything complicated. I mean, it can easily be solved. How do I identify whether a problem is DP or not? I really encourage you to watch the previous 2 episodes after this live stream. Let me share the playlist with you. I have talked about it in the previous sessions. So right now you don't need that, but if you want to answer that question, in the previous topic streams, I've talked about it when I started talking about DP. I've talked about it. I really encourage you to watch the previous 2 episodes. If we are ready to bear the cost of X, maybe, yes, that's also a good fact. I mean, if we want to bear a cost of X, maybe we can just use the square root of X by X. Maybe we can do dp of I and j as a mean cost or as, yes, these are all good ideas. So let's see that's what we can do. So yes, again, the first question is that what, and there's an important constraint as well that I need to emphasize on. N in this problem is up to 50. Our value of N in this problem is up to 50. So again, the first question that comes to mind is that, you know, this problem definitely looks like DP a little bit, and as soon as we want to apply DP on it and we want to see that how does DP work, can DP work or not. So the question is going to be, what are my subproblems. How can I define subproblems? So one idea that you mentioned is that we can maybe define dp of I and j that says that what is the answer if I consider the subgrid starting from the top left corner to cell I and j. So dp of I and j says that what is the cost to make this subgrid white from 1 and 1 to I and j. That is one idea. H and W can be 1. Yes. They can be from 1 to anything, to n. So, what do you think about this idea? Do you have also any other idea, maybe any other DPs? Maybe we can even have more dimensions. We do not really need to have at least at most two dimensions. Maybe we can, if we want, we can also have more dimensions. That is also a good idea. We have I, J, X, and Y, which the grid shows that, for example, the top left corner is I and J, and X, Y is the size of that rectangle. That also can work. So, yeah, the issue with just using I and J is that maybe, the idea is that maybe if we remove a subrectangle from it, if you want to use the smaller instances of dp, maybe you need, for example, the answer to, for example, this subgrid as well. So maybe if you only use the subgrids that one endpoint of them is 1 and 1, that is not going to be enough. Maybe you're gonna need also the answer of some of the subgrids such that their top left corner is not 1 and 1. So, when these DPs are gonna help each other to be calculated, when we want to calculate the value of all the DPs, maybe we're gonna need the answer for several sub-rectangles that one side of them is also not 1 and 1, not necessarily top left corner. So the question in here is that how can we define that? Maybe we can define it with using more dimensions. Do you have any ideas for that? So is the issue that I mentioned clear? The point is that the smaller DPs that you need might use grids that their top left corner is not 1 and 1. So you might not use them, those DPs. So maybe that is not good enough. Yes, that is very good. For example, we can have R1, C1, R2, and C2. Or for example, I1, J1, I2, and J2, for example. Yes, so maybe we can define dp of I1, J1, I2, and J2. And since n is up to 50, that is gonna be okay if we have dp of I1, J1, and I2, and J2. Because it is 50 to the power of 4. When my n is 50, even n to the 5th works. So I can spend 4 of my n's here. I can have n to the power of 4 possible DPs. I1, J1, I2, J2, which says that what is the cost if I only consider the cells from I1, J1 to I2, J2? What is the cost of this from I1, J1 to I2, J2? And so everything else is ignored. I removed everything else and I only want to solve these parts. I only want to solve these parts that we have in here. Okay. So Is it clear so far? Is everything clear so far? So what can we say about this DP initially? I mean, can we say that, can we give some upper bound for this DP? Well, assume that this grid is R by C. Okay, it has R rows and C columns. Yes, the cost of H by W rectangle is maximum of H and W. Yeah. So assume that this subgrid is R by C. R is definitely I2 minus I1 plus 1. If I used inclusive intervals, it's gonna be I2 minus I1 plus 1. C is gonna be J sub 2 minus J sub 1 plus 1. So if it has R rows and C columns, without loss of generality, assume that R is greater than or equal to C, without loss of generality. So also C can be greater than or equal to R. But without loss of generality, we can assume that R is greater than or equal to C. The other case is can also be solved in the same way. So without loss of generality, I assume that R is greater than or equal to C. Then what can we say? What can we say about our cost? Can we say any fact about our cost then? Any upper bounds for it? So initially, we know that, for example, R is going to be greater than or equal to C, for example. Yes, maximum of R and C. And what is maximum of R and C when R is greater than or equal to C? R, yes. So our cost is going to be at most R, because in the worst case scenario, I can, in one operation, choose the whole subgrid in here. I can choose the whole subgrid, and its cost is going to be maximum of R and C. And what is the maximum of R and C? It's going to be R. So we can say that our cost is going to be at most R in this case. Right. So now we know that the cost is at most R. Now the question is, what is the question? The question is that, can we solve it with cost less than R or not? So the question is whether we can solve it with cost less than R or we cannot. The current problem is 1198D. This one. So the question is now that if we can solve it with cost less than R or we cannot solve it with cost less than R. So assume that the answer is yes. Wait a second, let's see. I think my tablet is crashing again. Okay. So the question is that if we can solve it with cost less than R or we cannot solve it with cost less than R. So assume that the answer is yes. We want to see if the cost less than R can be achieved or not. Okay, let's assume that it is. Let's try to find it. Assume yes and try to find it. I'm trying to find a way when I have this R by C subgrid and without loss of generality, I considered, I assume that r is greater than or equal to c. Now I want to solve it with cost less than r. How can I do that? How can I solve it with cost less than r? Well, I say that if there exists a solution with cost less than r, then I can say some facts. Can you say that? What is this fact? So I want you to say that if there exists a solution with cost less than r, then you can say some facts. I mean, that solution has some characteristics, has some property. So yeah, these ideas are good. So at least one row must be completely white. Okay, any other idea? This is very good. Smaller than c square. What do you mean exactly? So these are good things that you're mentioning. Yes. So the point is that if there exists a solution with cost less than r, hi, Hamza. So the question is that if there exists a solution with cost less than r, we know that, at the end we are going to choose several subrectangles and make them white, right? What is our total cost? Our total cost is gonna be sigma of, for example, assume that this is h1 by w1, this is h2 by w2, this is h3 by w3, and so on. What is our total cost? Yes, Harry, yes, that's a very good idea. This is almost what you're gonna do. So our total cost is gonna be the sigma of maximum of hi's and wi's, right? This is gonna be our cost, and our cost is less than r. We assume that we are looking for a cost which is less than r, right? So our cost is gonna be less than r, and the cost is gonna be equal to the maximum of hi's and wi's. Now this value is greater than or equal to sigma of hi's, sigma of the height of this subgrid. And can you say that what is sigma of hi? Why I wrote it? Why I wrote sigma of hi? Why does this matter? What does it show? Can you say? So now I say that my cost is less than r, and it is equal to sigma of maximum of hi's and wi's, which is greater than or equal to sigma of hi's. So no, my question is that what does sigma of hi show? Rows, yes. So I can say that this value is greater than or equal to the number of rows involved. So what I'm trying to say is this: when you choose any subgrid, it involves, how many rows are involved in this subgrid? There are exactly hi rows that are involved in this subgrid. It covers hi rows. So I'm saying that when I consider sigma of hi's, I mean, in the best case scenario, no two of these rows for different subgrids intersect, and in the worst case scenario, in the best case scenario, in the maximum case, the number of rows that are involved in at least one of these grids is gonna be sigma of hi. So the number of rows that are involved in at least one of these subgrids in at least one of these rectangles So the number of rows that are involved in at least one of these rectangles is at most sigma of hi. And sigma of hi is less than or equal to sigma of maximum of hi and wi, which is equal to our cost, which is less than r. So if you consider all these grids, for each one of them you will cover, for each one of them we know that a set of rows are covered by this one. And as we see, these rows might intersect as well. Even if they intersect, it's even worse. Is there gonna be, the number of rows involved is gonna be less than sigma of hi. So, but in the worst case scenario, in the maximum value that they can have is sigma of hi. So each one of them covers several rows. The point is that if you sum up that how many rows each one will cover, the sum of these values is less than r. So the total cost is gonna be less than r. So there exists, so this is the main fact, this is the important fact that I say. If the cost is less than r, then there exists a row that is not involved in any of subrectangles, in any of the subrectangles. Do you agree with this? So I say that if our cost is less than r, then you can always find a row. You can always find the row and say that this row is not in any of the subrectangles. So all the subrectangles will not use this row. They are all either completely above it or they are all below it. So there exists a row that nobody uses it, and definitely it should be fully white. Definitely it should be fully white, because otherwise it needs to be involved in at least one of the subrectangles. Otherwise it needs to be involved in one of the subrectangles. So it needs to be fully white. So if the cost is less than r, there exists a row that is not involved in any of the rows. Is it clear? If it is clear for you, please again use the emoji. Yes, exactly. If c was greater than r, then we should say that cost is equal to c initially. I'm just writing the other case. Without loss of generality, we assume that r is greater than or equal to c. But if it was the other way around, if it was c greater than r, which we could have set cost to be equal to c, and then we say that if we want the cost to be less than c, there must be a column that is not involved in anything. So yes, the other case can be solved very similarly. You just swap rows and columns. Everything I said about the columns are true about the rows. Everything I said about the rows are true about the columns, if you swap them. Okay, is it clear? If I want to learn basics of DP, from where I can learn? Well, that's exactly why I'm doing this Friday topic streams. So maybe, my goal is that this playlist is gonna help you. This is not the third session of it, and the goal is to help you learn DP from the basics. So maybe you can try it. What you're asking in here, that is exactly the main purpose of these topic streams. So I hope that it might be helpful. I'm just saying that yes, I will make a topic stream about probability and combinatorics. Yeah. So I'm just saying that for this question, yes, I'm just saying that there must be a row that is not used. There must be. I mean, if I'm looking, my cost is right now is R. So this is the other case, but we are for now, without loss of generality, considering the case that R is greater than or equal to C. The other case is very similar. So we showed that there is a row that is not used. So what we can do, we can iterate over it, iterate over the rows. Then, so first iterate over the rows. Then do these things. First, check if they can be not involved in any of the subrectangles. What is the condition for it? What is the condition for a row to be able to be not involved in any of the subrectangles? Can anyone say that? I mean, if a row is not going to be involved in any of the subrectangles, well, it must be fully white. Yes, and n to the fifth is okay. There's no issue with n to the fifth. Yes, exactly. If it is not going to be involved in anything, it must be fully white. So otherwise, it's not possible for it to not be involved in any of the subrectangles that we choose. So if that's the case, come on. Wait a second. I don't know why it keeps crashing. Wait a second till it loads. So basically what I'm saying is that if you consider all these rows that are possible for us to ignore them, the second thing that we do is after checking, so first we do check to see if they can be fully removed, and then if they can, we just split the grid and use the smaller instances of our DPs. We use the smaller instances of our DPs to find out that how we can calculate this one. So when we consider a row that we say that, okay, I can completely ignore it, I do not really need to consider this one. I mean it is possible that I ignore this row. I have a for over all the possible rows and check if they are fully white, if it is possible for them to not be involved in any of the subgrids. I consider the case that this one is the one that I'm not gonna use. I know that if I want my cost, to be less than R, there must be an unused row. There must be such a row. There must be an unused row that I will not choose any rectangle that have intersections with it. So I can do an iteration and fix that row. I can say that, okay, let's assume that this row is that row. Then I know that all my operations must be fully on top of this row or on below this row. So I can say that, okay, let's solve this let's see that what is the DP of these parts and what is the DP of these parts. Let's see that what are these values and add them up. This is the case that this row will not be used. So the parts above it and the parts below it can be solved independently, and you can just add these two values up and just take your final answer of your DP as the minimum of itself and this case. So this way easily you can calculate the final answer. So first you set your cost equal to R. This is the case that R is greater than or equal to C. First you set cost equal to R, and then you're searching for a situation to find the cost less than R. You know that if your cost is going to be less than R, you need to find a row that is not going to be used. Then you iterate over all the possible rows. If you can ignore them, if you cannot using them, you will consider the case that you will use this part and this part. I mean, you will never use this part, this row, and you solve the subgrid above it and the subgrid below it independently. And this way you can calculate the final answer. You just add these two values up and see what is their total sum, and just take your DP mean equal to that value. Is it clear? And yeah, for example, if we want to find out if this row is fully white, we can, for example, use prefix sums in each row to see that how many white cells there are. For example, there are other ways as well. But for example, one way to see that in a row, if this row is fully white, we can just count that how many rows we have in each prefix of each row. And this way we can find out how many white cells are in this interval of this row. And that could help us to find if there are all white or not. So is it clear? If it is clear completely, please use this emoji again or put a plus, otherwise put a minus. Let me see if I missed anything. DP of this row is equal to 0. The DP of the row does not matter. I just care about DP of this part above this row and this part below this row. So this row is fully white and I do not care about this row. I say that I'm considering the case that none of my rectangles has an intersection with this row. So the parts above and the parts below can be solved independently, and I will find them independently. And yes, if when I have a 4 on my rows, I need to check if the number of white cells in here, if there is no black cell in here. I want to check if there is no black cell in here. There are two ways that I can do this. One of them is prefix sums. I can just fix that if I go to every cell, if I go up to every cell, how many black cells I have so far to that cell. And then I can see that how many black cells I have in here, and I subtract from that the number of black cells that I have in here. And this way I will find out that how many black cells are in the middle. So this is one way that I can find that how many black cells I would have in here, and that must be 0. Or I can also use another DP and try to find out that for any cell, what is the first black cell to the right of it. So if the cell is black itself, its DP will point out to itself. If it is a hashtag, it will point out to itself. Otherwise, it will point out to what it's the cell right to its right is pointing to. So for each cell, I will find out that what is the first black cell to the right of it. I'll find this value, and then I must check that the dp of this cell is outside of this rectangle. Only in this case, this row is gonna be empty, and there's gonna be no black cells in this row. Is it clear? So I should use one of these two values, one of these two solutions. And then when I fix an empty row, when I fix a row, I iterate over all the rows. I first check if this row is completely clear, if there is empty. There's no black cells in this row. If that was the case, I will solve these two parts separately, and I say that my dp will be mean equal to the sum of these two dp's, because I'm considering the case that none of these rectangles will have intersection with this row. So I'm considering the case that none of these rectangles have intersection with this row. So all of them are either completely on top of it or are completely to the bottom of it. So they are completely above or below this row. So I can solve these two parts independently and add their values up. Okay, is it completely clear? Nice, nice. Okay, so today we've discussed about LCS and we solved this problem MC. Let me send the links of the problems again. We've solved this problem MC, and we solved this problem rectangle painting. We couldn't talk about prefix sums, different types of prefix sums, but we will talk about it in the next sessions. As you know, the next week is gonna be a topic stream on graphs, and so for now we're gonna have a little bit break from dynamic programming after these 3 sessions, so that everybody can also catch up, and if they won't watch the previous sessions, and then from the next session, as I said, we're gonna move on to graphs. We're gonna discuss graphs in our next topic stream, and then but we're gonna come back to DP in the future after some time. Can't we just use dp of RC1, RC2 to check if row R is 0? Yes. That is also true. Yes, that is also wise. Yes. So let me also share this with anyone. So one of the ideas that you're using, you're saying, I haven't read all of the chats because I missed some of them, so I didn't see that, but thank you for mentioning it. Yes, this is also a wise way to find if a row is clear and there are no black cells. Yes, we can just see that what is this if this is in row number, for example I, and this is cell J1, this is cell J2. We can just see that what is dp of I and J1 and I and J2, and if this dp is 0, it means that this is fully white, otherwise it has at least one black cell. That was very intelligent. Great, that was a very good idea. So we can just check the dp of that row, and if it was 0, we can say that it is fully white, otherwise it should not be 0 otherwise, because we need at least one operation. So if it is fully white, if it is 0, then it means that it is fully white. Great. Thank you very much, Red Beast. Up to what power of n we have to come up with solutions in the customer, like where? Yes. So in here our solution is n to the 5th, and it works well. And in general, you know, if your time complexity in general is less than 10 to the 8th, it is good. Less than or equal to 10 to the 8th, it is good. It will be accepted in total. I'm just saying that if you multiply everything by each other, for example, if you multiply them and see what it is, if it is less than 10 to the 8th, it is good and it is accepted. If it is more than 10 to the 9th, it is bad and it is not gonna get accepted. I mean, only in very rare cases, for example, when the time limit is so high or your operations are really, really fast. But in general, it's not gonna be accepted. But when it is in between 10 to the power of 8 and 10 to the power of 9, in this interval, it depends really. So you can say that in this interval from 10 to the 8th to 10 to the power of 9, it depends. So try to solve everything in less than 10 to the 8th. In most of the problems, there exists a solution that it's going to be in less than 10 to the power of 8, but in some of them there is not. In some of them, the solution is in this interval. And that's why the time limit is a bit high, so that they can make sure that if you solve the problem, you can get accept from it. And sometimes you need to just try to use fast operations, fast in, see out, etc. So in this interval, it's gonna be a bit challenging to accept it, and it depends really that if you get accepted or not. And if it is greater than 10 to the power of 9, it doesn't get accepted. So if you have some n and you want to find out what is the biggest power of n that you can get accept from it, you can just think of this. And if you can do it in a way that it's going to be less than 10 to the 8th, it's going to be great. If not, then you need to do it in this do it at most to 10 to the 9th. I hope that it answers your question. Yes, the total time complexity, yeah. Our total time complexity is O of n5, n to the power of 5. So in our solution, we have n to the 4th dp states. Each one of them will be solved in O of n. Each one of them will be updated in O of n. So in total, it's going to be O of n to the 5th. Is it clear? Right? Do you agree with this? It is O of n because we just have a 4 on all the rows. I mean, when we are solving this rectangle, this subtable, this subgrid, we are just saying that, okay, when you want to find it, first I said that dp of I1, J1, I2, J2 is equal to R, and then I had a 4 on all of the rows. This is where we have n. I have a 4 on all of the rows, and in each one of them I say that I consider that, okay, if I'm not going to use this row at all, then I will solve it from dp of I1, J1, and if it is row I minus 1 and J2 plus dp of I plus 1, J1, I2, J2. So I have a 4 on all of the rows if they are empty. And how do I check if they are empty? I can just consider the dp of this subrectangle. If this dp was 0, then I can ignore it and solve these two parts recursively. I mean, I've saved them in dp. So use those values, add them up, and get the answer. Yeah. So is it clear now for everyone? If you are completely okay with this, please again use this emoji or put a plus in the chats. So you see that this problem was not very hard, right? It looked like it is very hard. It was div1d, its difficulty was 2300. But when we tried to solve it, it was not really hard. It was not really hard to solve it. With just several observations, we could just solve it, right? Do you agree with this fact that it was not really that hard? It was solvable. So I hope that you completely understood it and you can accept it. I highly recommend you to try to accept these two problems, MC and rectangle painting. And I hope that you enjoyed this live stream. If you had any suggestions or any comments, make sure to let me know in the Telegram channel here or in the comments below on YouTube or in our Discord server, wherever that works the best for you. Thank you a lot, Lily. And also, if you want, you can like the video or subscribe to the channel. That is something that I think if you want to support my work, you can do that. There's no pressure on you for doing that, but if you do, that's gonna be helpful. So, do you have any questions? Any other variation of the problem with block cells instead of whites? Any idea? So, oh, that is interesting. Yeah, that is interesting. Yeah, you can think about it as a bonus. So you have another variation suggested by you that was creative. So we can consider another variation of the problem, like for example, instead of white cells, we have block cells that you cannot use. Also, you can maybe think of just having white and black and blocked cells. So there are some cells that must be in lattice one rectangle. There are some that must not be in any subrectangle, and some that can be or can not be. I mean, they can both be or not. So yes, this is something that you can think about. Yeah. So again, thank you very much for joining today's live stream. I'll see you in the next live stream. That is a very good question. I have two microphones. I had a microphone before. If you see the previous videos, I had a microphone. Then I bought a microphone that was way better than that, but it is not working properly. When I was trying to use it in the live streams, everybody was saying that they cannot hear me. So I had to just use the laptop's microphone, but I will fix that. I either fix that or I will take back the old microphone that I had previously, because this way it's not good. But yes, and the FBI did not come this time. In our last topic stream, FBI came 3 times. So yeah, thank you very much. See you next week on graph topic stream. Thank you again, guys. Bye bye.